behind it. Say machine learning algorithms, you can see the learning, there's a learning there. It means they learn from data. Okay. So once you have data, what the algorithm do is to repeatedly perform a task. Okay, it repeatedly performs a task and it gets feedback from that task so that it can update how it will perform in the next stage or in the next iteration. Okay, it's basically like learning when you are learning something. So for example, if you take an example of maybe a fire, maybe as a kid, you see a fire burning and you're fascinated by the whole idea of, oh, this is very beautiful, so let me play with it. And you touch that fire, what will happen? You will get burnt. So once you get burnt, you instantly know that, okay, next time I see a fire, I should not play with it. Why? So you've learned to not play with the fire because you got feedback from the fire. So we can liken that process of getting feedback as a cost function. So what machine learning algorithms do is to, for example, if they are trying to predict the prices of house, let me go back to that. So in gradient descent, if it's trying to predict the price of house and you have data, you give it data for house price, data for square feet. If you give it 10, for example, 10,000 square feet, it will predict something that is totally wrong. So for example, it might predict 10 million for that. For 10,000 square feet, it might predict 10 million. So now you know the original value, you know the true value because you are the one programming it, you are the one training the machine. So you know that the original value or the true value is supposed to be, say, 3, for example. That's 3 million, but the algorithm predicted 10 million. So what you do is to calculate the error that the algorithm made. So once you calculate that error, the error between what it's predicted and what was the true value, once you calculate that error, you cannot adjust the algorithm to say, okay, what you predicted was too high, come down a little bit. So in the next iteration, the algorithm knows that, okay, from my previous calculation, I was too far, so I'm going to step down a little. So maybe in the next iteration, it came down to 6, and the true value is still 3. You calculate the loss again, or you calculate the error again, and tell the algorithm, okay, still come down a little bit. You are still far. You are far to the right. Come down. So the next iteration, it comes down again to, let's say, it's predicted very low, predicted about, let's say, 1, for instance. Then you say, no. You calculate the loss again. You tell the algorithm, you are too low this time. Come to the top. So that process of calculating, predicting, calculating error, adjusting your line, that's what's called gradient descent. That's gradient descent in action. Okay, so typically that's how gradient descent works. Makes prediction, calculates the error, then adjusts its parameter. So it's going to do it repeatedly for a long time. So after doing it for lots and lots of steps, it will approximately get values that are closer and closer and closer to the true value. Okay, so we can use, there's this example that we can also use, that you can liken gradient descent. You can liken gradient descent to someone that's on a mountain. Okay, yeah, something like this. So let's say I use this. So what you are trying to get to this point. So this point is the point where you have the lowest loss, the lowest error. There's no error again. So once you get to this point, you know that yes, the algorithm has gotten the right values, so you can stop training. But at any point when you start training, your error might be anywhere. It can be here, it can be here, it can be here, it can be somewhere here. So for instance, say we start here. This is where your error is, or we can call it cost. So this is where you start. So after making prediction, calculating the error, the algorithm, going to send the algorithm, okay, step down a little bit. It steps down to this part. It goes again, steps down a little bit, it steps down. So it's as if you are repeatedly moving down till you get to the lowest minimum. Then you can stop learning. Okay. Also, let me just chip in something. Let me see. No question yet. Also, you can see that it is moving downwards, 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 downward. But how will it know how far to move? So you can see why do we not just move from here straight down to here? Or why don't we just move in bigger steps so we can quickly get to the end? So these steps of how far the algorithm should move is called the learning step. And you can adjust that using something called a learning rate. Learning rate is simply telling you the cost or the set how far or how big to jump. Okay. So if you set the learning rate too big, it might jump maybe from here, it will jump to somewhere here. Then when you do it again, to jump above the minimum and come to somewhere here. Okay, so that's if the learning rate is too big, but sometimes it can be too small. So it will moving in small steps like this, and it will take a long time for it to get to the lowest. So you just need to adjust to get like the perfect or close to perfect learning rate, and that is trial by error. So you have to try different learning rates and see which one works. So that is called the hyperparameter tuning, where you try different learning rates and see which one is the best. So, but we're not going to that. That's deep learning. But basically, that's how gradient descent actually works. Okay. So, meaning the cost function is important. The cost function is just simply a formula for calculating the loss and the error. So, and I've mentioned that to you. So, there are different types of cost function. The most popular one is for linear regression will be mean. You can use mean absolute error or mean squared error. Use any of that. Okay. Let me come back here. All right. So the core focus of machine learning is to learn from the data we expose it to, and this I've explained all this. Okay. So how do we minimize the cost function? I told you about that. We minimize the cost function using gradient descent. So when you start learning, when your algorithm starts learning, the cost function is going to be very high, or the error is going to be very high. But with time, as soon as you calculate the cost, you move in the direction of the right value, the cost function starts getting smaller, smaller, and smaller till you get to the minimum, whereby it cannot reduce anymore. So before I continue, any question on that, on this part, before I continue? Does anybody have a question on that?